Hey folks, I'm Sumit. I'm the founder at AppFormix. Kamesh, thank you. Thank you, Jeremy. So, what our mission at AppFormix is to enable you to build a better cloud. And what we mean by a better cloud is a cloud that's easier for you to manage, easier for you to operate, and is more reliable, is more efficient. As Kamesh was saying, Mirantis does a pretty awesome job of getting these clouds up and running. What AppFormix focuses on is monitoring how these clouds are running, how is your cloud running, doing real-time analytics to figure out what's working, what's not working, and in doing that, improving the reliability of your cloud. So three the three main things that we deliver for you. The first one is we bring you infrastructure transparency at scale. No matter how small or large your infrastructure is, we give you complete visibility of all the applications that are running on your cloud infrastructure. Right? All cloud infrastructures tend to be multi-tenant. We can in real time inform you how your different tenants and their applications are consuming your cloud infrastructure. The second big challenge in cloud environments is that they all share. Many times applications compete with each other for resources. We can identify resource bottlenecks as and when new applications spin up, as they scale down. We can identify where they're constrained for resources and help you fix them in real time. And and the third goal that we have at AppFormix is essentially to enable this this world of cloud native applications hosted within your enterprise where they can use APIs to better understand how the infrastructure is performing to better build the applications. So the way we do this is through a software solution, what we call is a real-time software solution that enables you to monitor your infrastructure, monitor how the different workloads are consuming the resources on the infrastructure. We also do all of the analysis in real time and tell you what's really going on, what's constrained, what's not constrained, what's healthy, what's at risk. And in doing that, we enable you to optimize how you're consuming your infrastructure, how the different applications consume the infrastructure. We can monitor all of the system resources. We consume all the metrics that are available in the system. We enable a whole bunch of new metrics as well. We allow you to set policies that guarantee performance to the different applications that are running on your infrastructure. And all of this can be consumed using APIs. We are an API first company. And of course, we have a very cool user experience as well. So the way all of this works is you install agents on your host. The installation process is completely automated. And if you're using OpenStack, we can automatically discover your entire OpenStack environment. The installation process from that point on is completely automated. The key thing here is that the agent installs on the host. We do not touch the virtual machines or the containers. And by just installing on the host, we can give you the complete breakdown of how all the virtual machines, the containers, or the applications running within those VMs or containers are consuming the resource. On top of this, we of course have a central management system. The management system can run within your enterprise, or we can run it in the cloud for you. So this is just a quick overview of our dashboard. It's a what I call it is describe it as is a real-time user experience. We can monitor all of the resource consumption by the different hosts, virtual machines in real time. The data and the analytics are streamed directly from the host all the way to the dashboard. There's no database in the path here. There's no choke point really. And while we are generating all of these metrics, we're also doing all of the analysis, running several streaming algorithms to determine what is working and what's not working. If some host is unhealthy, we tell you right up front. You can, of course, get the breakdown of how the different virtual machines or containers are consuming the resources on the host. And it's a very fluid user experience. You can, zoom in, zoom out, You get all of the historical data as well. So it it's just this real-time user experience. Now, all of this information is also available through APIs. And then from a particular host, you can also jump into any single instance and see what the resource consumption in the instance looks like. So now what's unique about AppFormix is that when we are doing a monitoring at the host level, we can also break down what the IO footprint of every single service is. Even though the service is running within a virtual machine, we can tell you what the IO footprint of each virtual machine looks like. So each service looks like. So for example, here we have 3 different services running in this VM. We can tell you exactly what the resource consumption of each service is. And beyond just looking at basic metrics like what's the CPU and memory, we dive further into the application and we can tell you what's the latency of the application, how quickly is it responding to the requests, how many requests is it responding to. And every single metric that's visible in our system, you can also use these metrics to generate rules and get alarms in real time, which can be fed into your applications for your applications to scale better along with the infrastructure. So in terms of application, and as I was saying, we dive further very deep into the entire stack, and we can tell you very precisely what the latency of the application is, how quickly is it responding, what's the number of outstanding requests, how quickly is it responding, and things like that. So the product has 2 main components. The first one is insight and the second one is control. Insight is all about informing you how your infrastructure is operating and analyzing all of the key metrics to determine what's healthy and what's unhealthy. It also enables you to plan your infrastructure in a better way. What we've found in many situations is that after several years of use of OpenStack, many environments tend to have virtual machines that have just been spun up and are not consumed. So we can very quickly identify, situations where resources are being wasted. We can also identify situations where you could consolidate or where you need to devote more resources to. And then there is the control capability, where in real time you can specify how many resources a service should get, and we can dynamically change, the resource consumption of the service. So now it's time for the demo.
Hi, my name's Travis Newhouse, and I'm going to go into a little more depth here, showing you guys a demonstration of what AppFormix can do. Let me give you some context. So today we're going to demonstrate AppFormix running on top of Mirantis Express. So Mirantis Express is a public OpenStack cloud that you can purchase nodes on, and you have your own private cluster running that's supported by Mirantis. And they have a component called the Fuel Master. So when you sign up, you use the Fuel Master to deploy different OpenStack clusters. You can purchase a number of nodes. Maybe you want to purchase 10 nodes. You can assign maybe 3 nodes to one OpenStack cloud. You can create a different OpenStack environment with 7 of the other nodes. They can have different configurations, different uses maybe for your clients or your customers. And it follows the same OpenStack platform as standard OpenStack. So there's a controller node running all the OpenStack services. Then you have the hosts where the VMs are going to be executing. So then how does AppFormix fit into this architecture? What we have is a series of kind of control modules that we run on that we use to manage the hosts. So on each host, there's an agent, and that agent's going to be collecting data about the virtual machines and the resources on that host. The AppFormix controller is kind of the central piece that pushes configuration down to the hosts. It gets that information from an OpenStack adapter. That's basically listening to events inside OpenStack. It's using REST-based APIs to program the AppFormix controller. All of our APIs are REST-based and public so that you can use our software in a very automated fashion. Then the host agents, when they have data to generate, they are pushing it up onto a message bus. And again, that message bus publishes data in using REST and JSON. Anything can listen to it. We have our own dashboard to provide a user experience in real time. We have an analytics engine that's doing real-time analysis of the data that all the different performance metrics that you would like to monitor, network, CPU, including application level metrics like application response time, round trip time in the network, the number of requests, and we can then generate higher level signals that you can react to tune and optimize your data center. So instead of just getting the raw data, which is one option, our analytics engine in real time can kind of process the data and give you higher level signals like that you want to know, and it's fully programmable, and we're going to demonstrate that later on. And then so fitting into like a Mirantis OpenStack cloud, you have a lot of the control pieces for AppFormix running alongside Nova, Neutron, Keystone on the controller node, and then we have a piece that's running on the host. We deploy all of this from the Fuel Master, just like Mirantis does with all the OpenStack services. In fact, we'll be releasing a Fuel plugin in the near future. We currently, and I'm going to demonstrate today how we can do it with Ansible. So if that's a different environment that you're running in, you could also use Ansible, even if you're not using Fuel. So what I want to demonstrate for you today, I'm going to kind of go over five things. First is that the simplicity which we can install using Ansible. We can automate the installation into your Mirantis OpenStack cluster. Show how we integrate with OpenStack. So our software discovers all of the resources in your cloud, the hosts that you have, the virtual machines that you have. Anything you can see in Horizon is presented inside the AppFormix user interface. We also integrate with Keystone so that you have access control based on the same users that use your cloud. So if I'm a tenant and I have 5 VMs, when I look at the AppFormix page, I see those same 5 VMs. If I'm an administrator in the OpenStack cloud, I can see everything that's going on inside the cluster. So that's useful for the infrastructure operators who want to kind of see what's going on with their hardware, and it's useful for the tenants because they want to see what's going on with their applications. And then we'll show you how we visualize resource utilization in real time. Then I'm going to provide one aspect of how we do analysis to do health. We give a health score to your instances and your hosts to kind of give you an indication of whether things are looking good or looking bad, and we have some predefined configuration parameters that we use, and it's also tunable to tailor to your environment. And finally, I'll talk about what we call event stream, which is this real-time event generation that's one level up from just the raw performance data. Before I go there, so let's go first to okay, so first we're going to install. So right now we're doing it in 2 phases. I'm first going to install the AppFormix agent on all the compute nodes inside my inventory. Right now I'm just using one for simplicity and to keep us on time here. Basically, Ansible is going out, putting out the software, starting it up. Once it's done, I'm going to also install all the controller software. This is going to include the AppFormix controller, the analytics engine, the dashboard, and the OpenStack adapter. So, and once the OpenStack adapter has been installed and all these packages are up and running, we're going to contact Keystone, contact Nova, Neutron, and go discover all the resources inside your OpenStack cluster and populate them into our controller So the OpenStack adapter is going to basically be asking Keystone and Horizon what's out there, or not Horizon, but Nova, Neutron. Then it's going to use REST calls to push that data into the controller. And each of these services that we run, the way we package them is actually as a Docker container. So Kamesh was talking about containers, and definitely there's a space to play containers and OpenStack together, and we're actually using it to deploy our software so that each is running in its own container. It's very easy for us to not only deploy it, but to connect them together. So should be done in just a moment here. The OpenStack adapter's running now. Now it's going out and doing the discovery. Okay, so while that's there, this is Horizon, just to give you a sense of what this cluster looks like. There's two different projects. There is, like I said, there's a couple compute nodes, and now I'll bring it over to the AppFormix page. Just going to refresh, make sure it's got everything. Okay, let me just log out. I think it timed out. There we go. So this is our top level dashboard. What we're showing right now is a project-oriented view of the cluster from an administrator's perspective. So you can see there are 4 projects right now. 2 of the projects have 3 instances. 2 of the projects have no instances right now. As we expand, we can see what's going on. These are the 3 instances in the Acelio project. These are the 3 instances in the AppFormix project. And again, this mirrors what we saw in Horizon. So if you look at one of these Mongo 4s here, and we see something called Mongo here. Did I go to the wrong one? Yeah. Oh, that's why. I was even confusing myself, so I apologize. Oh, yeah. Okay. Thanks. I have my support team over there on the side. Help me out. So this one mirrors this Horizon. I'm sorry. We're running, like I mentioned in Fuel, you can run more than one cluster. And so we were actually running 2, one where I could do a live install and one where we already have some workloads running. So this one's actually a little more interesting because there's actually workloads going on. And like if I was going to show you Mongo 4 in the AppFormix test project, if I scroll down to the AppFormix test project, expand here, and you'll see there's Mongo 4. So all of the data that you're seeing here is being pushed directly to the user interface. That's a key aspect of our architecture, is that we're not polling. We're not going down to the nodes and asking for information all the time. We're not storing the information in a database, later going and getting a query out. This is real-time streaming. So when the agent has data, it pushes it out to a message bus. From that message bus, the user interface here is a listener, and it's getting that data that it wants to see. You can, if you want historical data, and we provide this, connect a database on that message bus. That database is listening and storing the data, and then you can later retrieve it out and display it. And as I mentioned, this is a project-oriented view. We also have a host-oriented view, which can be useful for infrastructure operators who kind of want to know what's going on with their infrastructure. So now what we see is a grouping by host. So node 22, node 24 have a different number of instances running on them. At the top level, you can see what is the CPU and network being used by the host in aggregate. Like the entire host, all the instances on that host are using up this percentage of the resources. So this is good for planning, right? People want to know what's going on. Do I need to buy more hardware? Do I need to migrate virtual machines? These kinds of things are very important if you want to optimize the return on your investment in hardware. We can drill down to a particular instance. Maybe we want to look at this see, demo Mongo 16. We can go ahead and navigate down to an instance. We can actually look at what's going on for a particular instance. And so on this virtual machine, you can see it's sending more data, lots of data coming into Mongo, storing data into the database. On the left, you see different applications that are running. Web, Mongo. Right now, Mongo is the most active application. You can see that it's what's using up most of the network. And if we want to take a look at like an application level metric, we can look at response time locally. So this is how long it took from the time a packet arrived at the physical host, the compute node, and for Mongo to respond, right? So it's very useful to know if Mongo is being scheduled with a good response time. You want to know is Mongo getting enough CPU to provide the experience that you need for performance inside your data center, and that's just on the hop from the edge of the physical network or the physical interface of the host to the software, right, through the hypervisor and through the operating system stack inside the guest. Conversely, we do provide the remote response time. In this case, we're not getting, Mongo's not making requests out, so we don't have that to display. But if you had like a client application, you'd want to know maybe what's its response time going across the network, and you could then compare that with the response time maybe at the server that it's talking to, and kind of start to understand what's going on. Is the network maybe slow, or is the service itself not responding well? So another aspect that we have on the dashboard is what we call the health index. This little green circle here kind of can tell you whether or not a host or an instance is doing well, or if it needs attention. Maybe there's a bottleneck. And like I said, we have different criteria that we have by default to determine what we think is unhealthy and what's healthy, and that can be tailored to your environment or to your applications. I think we're going to trigger some traffic or some load that will turn one of these to kind of bad health. I forget which one you're going to set up. So here you see that node 24 suddenly had a spike in CPU. It's crossing a threshold that is unhealthy. It's gone to red, so you can quickly identify that this is maybe a machine that you need to take a look at it. You might want to find out like what instance maybe is causing that. Maybe talk to that, find out why that tenant is suddenly using a large share. In this case, you don't see any instances going red, or you don't see any instances using a lot of CPU. What that can indicate is that the host itself, there's some software running on the host that's using up its resources. Maybe you need to go and check out. Maybe, who knows? Maybe an OpenStack service itself is misbehaving or eating up a lot of resources, and you want to kind of take care of that problem. And so you can give that amount of CPU back to your instances for the workloads that matter to you. And we can also provide that health index on an instance level as well. And all these metrics, all this analysis, we're not actually modifying any of the guests, right? So the virtual machines that are running here can be Windows, they can be Ubuntu, Red Hat, it can be whatever you want to run inside your guest. We don't require any software inside the virtual machine itself. We just put our agent on the compute node, on the host, alongside KVM and the like Nova compute. Okay, so
quick question.
Yeah.
Does your software give an alarm that maybe something is out of whack to or do I have to keep looking at the screen to figure out if something is wrong? And if it gives an alarm, does it give the analysis as to what could potentially have gone wrong? Whether it's a particular application, the host itself is going out of the software running the host is going to be on the same point.
Yeah.
Which is good.
Right. So that's perfect. You're leading right into what I was going to talk about next, which is that, like I mentioned a little bit earlier, but under the hood, all of this is API driven, right? And so our dashboard is one consumer of this data that we're publishing. You can write your own listeners to react in real time by consuming that data if you want to say, identify, a high CPU load, and I want to migrate. I want to migrate off that machine, or just want to, page my operator to let him know what's going on, if you can't take care of it in an automated way. So what I'll show you is sort of under the hood here. Let me see which one was. Can we put one other into the health mode again, like the host node 24? What I'll show you is quickly. I'll just show you what I have. I just have it in a script, so I'll remember what it is. But there's a curl command here, right? It's going out to check on the status of health for all hosts. Okay, and so if I run this, then what we'll see is we get back structured JSON that kind of gives us an idea of what's going on in every single host. So node 22, health is good. Node 24, it looks like health is bad. And that was the same node we saw earlier when we ran this trigger. And then inside of node 24, each instance, what's happening, is it good or bad? And this has a timestamp, so you can kind of know when this happened, because these events just will keep coming out. This was an example where I pulled the data when I wanted to find it out. We have also a subscription message bus, as I mentioned before, where you would be pushed this data, right? You would be pushed the state changes of when something goes between good and bad. I didn't want to have a listener on there and flooding the screen with data. But similarly, we can do it for get all the instances. And it looks very similar. It's just that we're not breaking down by the host in this case. We can do it, slice it by project, and we can slice it by host aggregate, which is a concept that OpenStack provides if you want to group hosts into for management purposes or for availability zones. And you kind of asked also, well, can I know why, right? Can I know why it's going on? I'm just going to show you quickly a sample of what some of the data looks like coming out of the metrics. So you can take this and then correlate what's going on. But this is kind of what's being fed on our message bus for a particular instance. We have lots of metrics basically at the system level. So we have memory percent, how much memory is being used, disk, CPU, and we provide both perspective of CPU from the VM itself, like what does the VM think its load is, like if you were to run top inside the VM. We also provide the CPU percent from the host's perspective, so you can understand this particular virtual machine is using 20% of the total physical CPU available on that host. Tells you how many vCPUs it has, the amount of swap memory that is being used. On the host, this is the host level metric, swap memory, as well as total memory usage, total disk usage. We provide at the host level I/O wait time, so you can understand if you're having slow access to your block device. Sorry, not I/O wait time, but I/O wait percentage of time spent waiting on the disk. And then all the CPU load for each physical CPU on the host is presented. And this is for a host, right? So if you want to know the application, then that's a separate piece of JSON that's coming out for the application with some of those metrics I showed you, like application response time, application request rate, response rate. Come back over here. And so just we publish documentation here for all of our APIs that you can basically look at what you want to do. So I'm trying to think of the best one I can show right now. But these are the APIs that, for instance, the OpenStack adapter, when it adds a server. If we do support other platforms, our focus is on OpenStack today, but if you wanted to integrate into a different kind of cloud platform and you need to say there's a new compute node inside the system, I'm letting AppFormix controller know. This is documentation that shows what fields you need to provide to define that server. And there's samples over here for the schema. You can, from this tool, even you can actually test out the API if you want right here. It's a tool called Swagger that we use to document this and make it easy to test things out. You can also get information, so you can get a list of, like I could get a list of all the servers. It's probably, but I need an authentication token, and I'm not going to go pull that up right now. Sorry. So the next thing I want to just talk about and show you is what we call event stream, and event stream is part of our analytics engine to kind of give you a higher order level of information. I showed you a lot of the raw metrics, but in addition to the health score, you can. This is another way that you can customize what you want to know about. Like if you are concerned about maybe over CPU, CPU load over a certain threshold, or maybe CPU load under a certain threshold because you want to power off a machine, and maybe you want to react to that event in real time and automatically power down machines, take them out of your cluster. That's something you can use. That's what this event stream is for. So it's a real-time big data platform that's doing all the analysis using streaming algorithms in real time at each compute node. So it's distributed. And as that data is collected, it's put through these the streaming algorithm to process the metrics and then generate signals about the health and performance of your infrastructure. An example that I'm going to describe right here is you could generate an alert for CPU percentage if the average over a 5-second duration is greater than 50% in 2 out of the last 3 intervals. Okay, so it's a mouthful. Let me show you what that looks like. Here's a plot of CPU usage. I've overlaid over it some boxes to kind of represent a 5-second interval. And what would happen is, the first 5-second interval, the CPU is not above 50% on average. Second one clearly is. The third one is. And so the event would fire here after the 2 out of 3 intervals. I think I might have slightly misaligned these arrows. The alert would become active until the time at which 2 out of 3 were not above 50%. So here you see 1, 2, 3. On this this event, the alert would become inactive, right? So we have 2 modes that you can configure. An alert is what I described, where it has state that the condition is active and the condition becomes inactive. The notification that we send out is on state change, so that it's not sending so much data that you can say, okay, send an event when it becomes active, send an event when it becomes inactive. If you want to have a little more raw data, you can configure the mode that's called an event mode, in which case every time the criteria would have matched, in which it would stay in the active state, you will get the event on every single interval. Right? So it's a little more data, but sometimes, depending on the use case, that can be useful. So now I'm just going to show you that looks like here. Okay, so we have a very similar rule here. On the 2-second interval. So we're generating an alert for CPU usage if the average over a 2-second interval is above 50% in 2 out of the last 3 intervals. And you can assign the severity of how important it is when this event fires. And this is showing a log of what's happening, right? So, and it's going to be updating in real time. We look at the CPU, the instant CPU alert. So here, and we can see that it's inactive. That means right now it's not, it hasn't crossed the threshold. It's not firing. If it were to become active, then we would see the state change, and you can see, know what host it's happening on, whose project it belongs to, as well as the severity of the event. None when it's inactive. And I'll just show you how you actually apply one of these. So we can do a host CPU. So if you specify a project, then this rule will be configured for all instances inside that project. So any instance that's running in that project will be monitored to see if it meets the criteria for the event rule. If you don't specify a project, then what it means is it's an infrastructure level rule. It's going to be applied across the physical host. So the data that's being analyzed is the data coming out from the physical host itself. So this is useful to monitor your infrastructure. So if we want to do an alert for CPU percentage, we can say when the average over 5 seconds, let's say it's above 30%, and we want 2 out of 3. Save that. So now we have host CPU here, the one I created. If we were to look and fire kind of a workload that generates that, I think what we'll see, oops, sorry, to expand. So CPU has gone above 50%. Take a look at our event stream. See that the host CPU has become active at this time. It started out inactive after we first configured it, or sorry, when we first configured it here, it was in learning state until it's seen enough intervals, became inactive. Once the CPU went high, then it became into the active state. We go watch, that CPU comes down. So now CPU is dropping, should be below our 30% threshold. We should see CPU alert. Our host CPU is inactive. Probably will jump to inactive here. Now it's inactive. And this data is also pushed onto the message bus. Each of these events, again, the dashboard here is just getting that stream to it because it's a subscriber on the message bus. So that concludes what I wanted to demonstrate today. Basically, AppFormix provides real-time visualization of resource utilization so that you can monitor your infrastructure utilization. We help you analyze the health of your infrastructure so that you can also plan your infrastructure and make informed decisions and get a high ROI on your investment in hardware. We also provide real-time control. That'll be for the next meetup. So, are there any questions?
Do you plan to integrate with Horizon at some point?
That's a really good question. At the moment, we are able to move faster with our product development cycle by not integrating with Horizon. As we mature, I think we will definitely explore that possibility. But we do have the Keystone integration. I actually didn't demonstrate that today, but you can log in as a different user and you can just see only the resources that you're entitled to see. And so, although it's not fully integrated with Horizon, our OpenStack integration is trying to be fairly complete. Any other questions? Okay, thank you very much.